Imagine the following scenario. A catastrophic event occurs, earthquake, hurricane, tsunami, anything that can sever the main power line going into a cell phone tower. Now, communication during a time of emergency is very critical if you're experiencing such an emergency. Our goal as a selective power controller is to extend the amount of time that communication is active during like a catastrophe in which the main power line to a cell phone tower is severed. We talked to a T-Mobile engineer regarding how the backup batteries work on a cell phone tower as soon as there's no main power from the line. And we were told that all of the technologies, including 4G, 3G, 2G, and any peripherals that are active on the tower at the time, are all turned on simultaneously, which puts a very large load on the batteries. The batteries will then discharge incredibly quickly. Now, Jason is going to tell you about our implementation in which we can conserve the power for a longer period of time.
The batteries that he's talking about are rated for about 48 volts DC, and that gets sent from the bottom of the tower all the way to the top of the tower where the antennas are. Now, as the batteries start to discharge, that voltage starts to diminish slowly, and below 42 volts DC, nothing is even functional. So what we did is we made a controller that can monitor this DC power that would go to these antennas, and we are making a relay. We made a relay box that would be able to secure power going to separate antennas, which would reduce the amount of power that the batteries are consuming. So we have a microcontroller at the bottom of the tower that technicians can program to set their set points to whatever they need it to be. And that communicates remotely with a microcontroller on the top receiver that allows that to actually control the relays. And we have a preset right now, but a programmer could hook up their laptop to reprogram the set points. And while the microcontroller at the top of the tower doesn't quite have enough voltage to actually control power relays that are that can take enough power to actually power these antennas, we've used an assembly of amplifiers that can actually operate these relays that are big enough to power these loads. And I'd like to open the floor to any questions.
So you say you use Wi-Fi. So what's the communication distance between the box and the
It's
top?
not actually Wi-Fi. It's
Sub 1 gig.
Yes, it's sub 1 gigahertz. Yeah, and we actually tested a whole bunch of different frequencies, and we found one that without an additional antenna could reach up to 80 feet. But that's like in an open field, right? So if we needed to extend that, we would definitely go buy another antenna. But if you come to our poster downstairs, we can show you what range we can get.
Yeah, with sub 1 gig, you won't have a problem with
Right,
range.
right, exactly.
How do you know which electronics you're going to shut down?
So that would be determined by whoever owns the tower.
Well, there's a preset version. So I think the preset is we first turn off mid-band 3G, then we turn off 4G. I think it's high band goes off first, then mid-band, then low band, and then the last thing to turn off is 2G. But that's just the preset. So the separate microcontroller at the bottom, there's a screen on it, and a user or technician can just come and select, oh, I want to turn off this technology if he wants to change from our preset values. But as it is, as soon as the backup power kicks in, ours will automatically turn off. So if the 48 volts starts dropping, once it gets to like 46 volts, it'll shut off that first technology. I don't think it's actually 46, but it'll reach a threshold, it'll shut off technologies automatically, and then the technician can change that as they want to.
We've actually set it so that it'll turn off the most power consumption, like the technology that takes up the most power first, because that just makes more sense if you want to extend the time that communication is available in an emergency.
Yeah.
Yes.
Plus, we don't need 4G because 4G is mostly going to be used we don't need streaming or FaceTime or any other functionality when it's an emergency. I feel like phone calls themselves are like you need to communicate with someone and tell them, hey, I need help.
So did you, two questions. Number one, who did what? And number two, did you come up with how much longer do you think you extended the length of time possibly in a cell tower?
Yes, okay, so I worked on the top of the tower for the amplifier that takes their 3 volts from their microcontroller that can amplify enough power to operate power relays, and they made those power relay assemblies that are big enough to power the theoretical load. And
I did the programming for the microcontrollers along with Kavon. And then there's a charging circuit that keeps the microcontrollers on when there's no more power coming from the main line. And that was done by Abigail.
And I was also part of working on the PCB implementation, as well as being able to take AC power that's generated, trying to turn it into a voltage supply that can be usable for the selective power control.
We actually ran out of time to like send our PCBs and have somebody else make them. So Jason made the PCBs and I just like soldered everything in. So we were like the technicians too.
Maybe in your bathtub?
No, so what we did was we got the copper clad, just got them from Fry's, and wherever I need the copper to stay, just paint pen over it, let that dry, and then mix it in etchant, a ferric
Ferric chloride.
Yes, and that eats away all of the copper that's not covered, and then you're left with kind of the layout of a PCB, and then just drill holes manually and solder them in, and she helped a lot with the soldering because she's really good at it.
Yeah, that's the old way, yeah.
Yeah, I did that a few times.
So do we teach a class on soldering here?
Yeah, she basically gave me a class on it. I mean, like solder wick, I didn't know that was a thing.
Yes, at least there is one of the freshmen sophomore classes where they talk about soldering, as well as we run workshops.
I actually took a soldering class at the workshop just in case we needed extra help. So.
All right, let's thank the team.